afternoon. Welcome back. This is Liam Recorder, cybersecurity instructor at WazU. This is the second session for the system admin class that began a week ago on the 2-week model. So this is the last lecture for this, and it'll finish up this class for the student. And then, of course, we get a nice 2-week break for the holidays, and we'll come back, and you should be in network defense. So we had covered last week some basics of what system administration is, spent a little time talking about cloud and virtualization and various tools that we can use to learn system administration skills and, of course, security related skills. This is, remember, a system administration overview class for our security program. We talked about various network components, routers, switches, et cetera, and continue to talk about different types of security related equipment like intrusion detection, unified threat management, on and on, all these acronyms in our field, of course. And then we, of course, talked about a lot of best practices, some very common things that'll get repeated again and again. Change the default passwords, harden systems, make sure you have a backup plan, et cetera, et cetera. We then talked a little bit about the operating system families, how technically there are 3, as most folks would cover it. The Macintosh, I shouldn't say Macintosh anymore, but the Apple OS family, iOS for the devices, iTV for the TV, iWatch, and of course the Mac OS for the main laptops and desktops. They do have a server add-on version as well. Then we talked about the Windows family, Windows Server, Windows X, all the out of date, but still 4 or 5% of the market, Windows XP, Windows 7, Windows 8, Windows 10, etc. All of these operating systems on the Windows family. And then, of course, we talked about the Unix Linux world. And if you remember, I even mentioned that reality is that you could argue, because really under the hood, Apple OSs are Unix based, you could really say there's really only 2 families. But because of the uniqueness of the way that Apple ties together their hardware and software and sort of manages and controls end to end their entire ecosystem, that's sort of what justifies it being a separate OS family. So there's the Apple family, the Windows family, and then the Linux, the asterisk Linux, the Linux and Unix families that are out there. Primarily of most importance to us are the Linux side of that, even though you may, in your future endeavors and work, run into Unix machines. As I mentioned, everything learned in this program and in any learning in future, almost everything that applies to Linux will work in Unix and back and forth. Obviously, certain software would only run on certain things, but the base commands are identical. And then we talked about shell scripting. If you remember, I told you I'd even come back to that a little bit, and so I'm going to, just briefly though, because the student in this has already cranked through all of this stuff and did really well on that assignment. So, but I do want to just sort of reinforce, and I'm going to go into a little bit of a screen share to show a few things. We, as I mentioned, we talk about shell scripting with a couple different languages, primarily Microsoft on the Windows side. We talk about PowerShell, and you'll see that I've actually here on the desktop, I've made this icon that I have actually named Windows PowerShell for scripting, because remember, there's one catch. By default, if you just come over here and type PowerShell and run one of these PowerShell applications, you're going to get errors if you try to run a script, because it's just going to launch in default mode. So we want to make our own shortcut, and then when you go to properties and look, you'll see that what I've done here at the end of the normal, okay, so here's the path for the, so it's system root, which really means Windows, C Windows System 32, Windows PowerShell version 1.0, PowerShell.exe. So that is what the normal icon, if you will just launch PowerShell. But I made my own shortcut so that I could basically have this additional parameter added on. You'll notice there's a space after the PowerShell.exe, and then there is this execution policy unrestricted. What that means is that when I run PowerShell with this icon instead of just a normal one, it'll actually pass in that execution policy unrestricted, which will unrestrict this one session so I can run scripts in it. That is a really critical thing. And so, and then of course I can run various scripts once I get PowerShell up and running. It takes a little bit to launch. And we'll get to a PowerShell prompt here in a moment, which looks very similar to just a command prompt. but you'll notice the PS in front because we're in the PowerShell environment. Now we can still type commands like take a directory and see what's there. And of course, since this is my home directory, it has things like my desktop, my documents, downloads, various other folders, obviously here, VirtualBox VMs, etc. And that's equivalent to the ls command on Linux, right? And so like, and so now the simplest scripts are nothing more than just a collection of things that you basically, commands you could type at the prompt yourself. But then of course we usually try to make them more elaborate like you did in the exercise. But the real thing I wanted to point out here, I think I have some right here in these work files. Nope, that's the wrong work files. That's Python stuff. Well, shoot, that's all right. I'm going to spend some time on Bash anyway. And so if we come over here, this is my personal server I've logged into because I wanted to just show the other side there. I just wanted to show a little bit. There's the trick of if you don't do that exclusion, execution policy unrestricted as a parameter when you launch PowerShell, you can't run PowerShell scripts. The trick on Linux is that if you don't have the permissions set correctly. So I have this script that it's not one I wrote, but it's a script. So if I take an ls of that script name here, you'll see that it actually has the appropriate permissions. Read, write, execute, read and write, read and execute, and read and execute. Just as a quick review from Network Foundations, but remember, the first slot is usually either a hyphen if it's a file, which this is, it's just a script, or it's a D if it's a directory, and then the next 3 represent the permissions of the owner, Lee. So Lee has read, write, execute. The user group, the group I'm part of, which is users, has read and execute, and everybody else has read and execute. So now if I was to just do this real fast, which is 600, and then rerun that command, that's the chmod command. We talked about that in Network Foundation. This changes permissions. There's different ways to do it. I like the numeric way, where you pass in a value, and it basically, what I've told it there is the 6 represent read and write permission, and the 0s represent no permission. So if I rerun this ls, you'll see that I still have read write permission, Lee, but the other groups, it's hard to select just 3, but the other groups, the last 6 slots, the user group and everybody else, they now can't even read this script. So if I try to run this script, dig script, you see it won't even autocomplete for me because it's not seeing that that's something that I can run. But I'm going to type it in because I'm stubborn, and I'm going to type in my own domain, and it's going to say permission denied. Well, that's because we don't have execution permission. So if it put it back the way it was, we use 755. The 7 is all permissions. So the first group, me, the owner, gets everything, read, write, execute. 5 is actually represents read and execute, but without write permission. And so if we do that, come back here, take a little look, you'll see that I've changed the permissions. The prompt here is actually disclosing that it's executable by marking it as green. And so now if I try to run this script and have it come back and give me the results, you'll see that that's what it does. It basically, this script, and we can take a quick look at it just real fast before we wrap up. This script basically says we're going to check the subdomain for all the different types of sort of known things that you might look for. A web server, a mail server, an IMAP, blog, a login server. And then it uses a while loop here to loop through, and basically it runs the dig command with some different parameters and uses the awk command to format that. This is a fairly complex script, relatively speaking, but what it's been done is it's basically allowing, instead of me having to do dig type of server that I want to run, I want to dig for the mail servers, I want to dig for the web server, I want to dig for, and I could run these commands over and over again and get the same information. Instead, the script will take a domain input and go off, and you can see it comes back and it found both the DNS machines, it found the mail server, it found who the technical contact for that domain is. So it found a fair amount of information just on one command, and I could get all that with multiple dig commands, and I could get additional information. But like if we just do a dig mcquarter.net, we're going to see that we don't get quite that exact same result. Instead, we get this type of result where it returns a lot of this information, but gives a lot more other information than that we might not need. And also, it's only telling us the high level. So, like, where's the web? Where's the mail? We didn't get any of that. So we could force it by running dig again and passing in the MX for getting the mail records, or we could pass in another type of search. And what this does, instead, the script automates that for us so that we get all of that run in one run, and we get a nice output of the data that we're looking for. So we get the IP address, we get the DNS servers that are tied to it, we get the mail server that's tied to it, etc. So basically, that's what scripting is all about. The two catches are in the PowerShell world. By default, you can either turn the permissions restriction on scripts off. If you do that, then that's actually not recommended, because then your machine is exposed to, say, if somebody somehow executes or gets you to click on a PowerShell script, and now they can run and do things and you might be compromised. So it's better and safer when you're working on scripts to only set up a custom icon like this with that, down here in properties. You can, copy one of the existing ones or just make one from scratch, and all this information's in the courseware. But ultimately, this is the part you're having to add on at the end, is that way when you run a script, a PS1 script will actually be executable within that environment. So I was going to do a little bit more. I realized though that I've swapped servers out on my network, and one of my demo servers had a lot of my scripts on it. I'm going to have to pull those off and put them on another machine for future. But as I said, I know in this case that the student in question has already finished that, so I'm not going to spend much more time, even though I did say I would talk briefly about it. Obviously, trying to get my screen to go back the way I want it to go. That is not what I wanted. Sorry. Oh, I know what I'm doing. Okie dokie. There we go. Let's return to this mode. So, moving on. To wrap up, we have, of course, 5 more lessons. There's 10 lessons per course, and the vast majority of courses. We still have one that's in a different format, but it's equivalent content. Nonetheless, when we covered the first 5 up through shell scripting last week, touched on shell scripting a little bit more, just to do a little quick demo there of those caveats. Make sure you got your permissions set on Linux, Unix, or Mac. Remember, Mac has Bash. You can do Bash scripting on a Mac. And then, of course, on PowerShell, you got to set up that execution policy. So the last part of this is the last 6 lessons, or 5 lessons, but starting with lesson 6, it is an overview of something we are going to spend a lot more time with in the coming classes, but that's topics of vulnerability assessment and penetration testing. These are very important concepts to understand, and they do dovetail into the system admin role, even though they're more often than not thought of as in the cybersecurity space. But sometimes, depending on the company and the size and who does certain things, system admins will be doing some of this work themselves. They run their own checks and scans to make sure things are secure, even if that's under the direction of a security team. The security team may be doing their own in addition to double check, or they may be doing different types of checks and scans. But many people confuse vulnerability assessment and pen testing. And so this is sort of your first exposure to it. And most of our students' case at this point, you'll get some hands-on in the next course with this, and we'll come back to it in later courses as well. But there is a difference. Vulnerability assessment, vulnerability scanning is all about finding a possible vulnerability. So there's all kinds of different tools that we can use, and you're going to learn a lot of them in our program, like Nmap and Linus and NIC2, different tools that you can run to scan a computer, to scan a server, to scan a router, to scan a website. And these tools will come back and report if they have, they'll try common things. They'll check the versions of stuff. They'll try to pass in certain common commands that, if they know is a vulnerability at a certain version level, and they'll come back and report, oh, this website allows for SQL injection. This website's got an out-of-date library. We're using an old version of PHP, which has these potential vulnerabilities. Now, vulnerability assessment is just identifying vulnerabilities. And so in many cases, organizations will have people that's their job. They run vulnerability scans on a fairly regular basis. They may be automated as part of a larger security monitoring, network security monitoring type of management system. so that every so often these are automated. Every night at midnight, we scan certain machines to make sure what ports are open, what services are running, are there any vulnerabilities, has anything changed since the last scan. But vulnerability assessment just does that. It reports the possible vulnerabilities. Now I say possible because if it's found a vulnerability, there's two reasons it may not be an issue. One is it may be a false positive and it may not really be there. It may have been a misread. Technically, the information, kind of glitched or packet drop or any number of reasons, or just, well, based on the versioning, we know this is Apache whatever, or an Nginx whatever, or PHP whatever. And at this, these vulnerabilities are possible at that level, but it might depend on a sub level. And so maybe you've patched that vulnerability, but the system is still saying it's possibly there. So it could be a false positive. The other thing is that you might find a vulnerability that's being mentioned, but yet it's still not an issue because you've taken some other step to eliminate that being a possibility. You've set up custom firewall rules that, you know that if somebody comes in this way through this port, they can try to get in. So you block that. So the system may show a vulnerability, but you've taken other, as part of defense in depth, you've taken other steps to defend against that. Vulnerability assessment are very common. There's a lot of different tools. They can be done by in-house teams, and there, of course, are security firms that either are smaller boutique security firms, sort of like myself, that you could be hired. You could, technically, somebody could hire me and say, "Hey, come check our systems. We want to know what vulnerabilities you're able to find from the outside, from the inside, from whatever." Vulnerability assessment is that. Penetration testing goes a step further. In the vast majority of cases, the pen tester will do a vulnerability assessment. Now, that I say the vast majority, there are exceptions. There are times when, in effect, especially internal, a team say, okay, I do the vulnerability assessment and I hand that results to you as the pen tester, and you sit down and you say, okay, these look like they're promising. Let's see if I can really get in. Let's see if I can exploit that vulnerability. Let's see if I can get to a command line. Let's see if I can inject some commands into the system. Let's see if I can pull some files off the system. And then if we can, obviously we need to go fix those problems. And so vulnerability assessment will find and report on vulnerabilities. Penetration testing will validate those vulnerabilities. Will show that they're exploitable. And so with penetration testing, the same deal again. These could be automatic sometimes, more times than not. It's not as automatic, even though there are services and providers out there, including cloud-based services that do it. There's all kinds of different penetration testing tools. As we're going to learn, many of the tools, one that you're going to learn to love, or you're probably going to change fields at some point, is called Nmap. Nmap is a tool that can be a vulnerability assessment tool. You can do scans and all kinds of great stuff, but it actually also can help you with the pen testing because it has a whole scripting set of modules that allow you to validate whether the vulnerability is exploitable or not, and they can check for known things, and it's always added to as more stuff comes out. If you're like a third-party pen tester, then of course you would ultimately reach an agreement with this company. Okay, I'm going to check your web server. I'm going to do it in this period of time. I'm going to use these types of tools. You're going to, if you are afraid that anything I do might bring the system down, we're only going to do it at off hours. We're going to agree the whole thing. I'm going to come and run my test. And then I'm going to ultimately prepare you a report that says, okay, the vulnerabilities that were found were these were ones that I literally could take advantage of. So I was able to get a command prompt on your server through this vulnerability. And I could have gone further, but that's then where a pen test usually stops. Because, like, for example, especially as a third-party pen tester, you wouldn't want to log in to a client's machine and, you see that you have full access to the database. So you could read all the credit card information that their clients have. You don't want to do that as a pen tester. I don't want that data. I don't want the responsibility. I'm not trying to be a black hat. I'm not trying to steal that. I'm just trying to show it could have happened. And so then I'm going to report, you see, I can do like a select count and show I have access to the database, but I'm not going to actually retrieve that information because it's confidential, right? Even though I'm a contractor for them, but I don't want to violate anything, and I don't want to take on any liability of having that data. All I'm trying to do is validate to the company, yes, this can happen. So if I could have done it and it was a black hat hacker, they would have pulled all that data down and had all your customers. So you need to fix that hole. So these are very important topics. We're going to learn a lot. This is an overview of it just here in System Admin because all system administrators need to know about this. And as security professionals, we're going to work with system administrators. Many times, if you're in a mid-sized company and a small security team, many times some of these day-to-day routine things will be automated, or you'll have the system admin, the IT team help you do these things on a regular basis. Whoever's responsible for that web server will run their scans. If there's a new port open, something's up. Maybe somebody's gotten in and opened the back door, right? And so you need to be aware. So we run these types of scans. But then we also periodically will do pen testing so that we can validate whether there's anything that's an issue. And especially if there's like a new release of our website or new release of our application, we are upgrading servers, patching servers. What happened? Did that create a new hole? Did it fix something, but it opened up something else? This is an ongoing kind of process. And as I said, we will come back to both vulnerability and in the very next class. Actually, you're going to get hands-on with Nmap and a bunch of tools, including one called the Open VAS, which is the Open Vulnerability Assessment System. And so one of the more intensive virtual demonstrations we do within our topology, where you have to run a scan against a vulnerable machine, and it takes a little while to run. That's one of those assignments in that class network defense that I really recommend, and I'll talk about when we get to it next year. But to dedicate a little bit of time to it and don't have a bunch of other stuff running. Let it do its thing, and then you'll just be blown away by this output of all of this stuff that was found. And then, of course, we'll learn other scanning tools to be able to find other vulnerabilities. And, of course, we're going to learn a lot of attack methods, and you're going to breach databases and breach systems throughout the program, especially network defense and threats and vulnerability. And we'll touch on it here and there in other places as well. So then, as we move on into lesson 7, lesson 7 is on secure protocols. We know what protocols are, right? Like HTTP, okay, Hypertext Transfer Protocol, or FTP, File Transfer Protocol, or SSH, Secure Shell, things like that, right? There's all these different protocols. What do we mean by secure protocols? Well, in many cases, it's actually really easy. There's HTTP and there's HTTPS. HTTP secure, or SSL encrypted, TSL encrypted. There's a big move to move every site to that format. There's some, I guess in this day and age, I'm slowly losing this argument, but I've been one of the slowers to adopt it because I feel like there's an argument that a lot of stuff, if you're just serving up the restaurant menu, why does that need to be encrypted? But nonetheless, that's the move we're moving toward, and more sites are switching over to the HTTPS. And definitely you want that if you're Amazon or you're a bank, right? You want that little lock symbol, even though that can be spoofed. But you want to at least have that encryption, that confidentiality that's going on when you're transacting that information with your bank or with Amazon or whoever. And a lot of that going on this time of year, right? So many cases, it really comes down to, if we're trying to secure our organization, then we want to use the secure protocol. So we would want to implement HTTPS on our machines, on our web servers, on our remote access, whatever it is we're using. Same thing, like there are 2 protocols. One's still out there, but not used very often for this very reason. But there's an old protocol called Telnet that you can use to connect to a machine and get a remote command line. And it was the original. As a matter of fact, you can argue it's one of the first killer apps of the internet. In the early days of the internet was developed in large part. There's lots of reasons. People talk about all different kinds of reasons why the internet was developed the way it was, via the ARPANET and into the internet, survive a nuclear war and all this. But one of the really biggest reasons the internet was developed was because before the internet, and before the advent of that ability in the ARPANET, if you were, say, some kind of researcher and you needed to go get, you needed to crunch some big data, maybe a defense contractor or some kind of researcher for the government or whatever, and some point in 50s, 60s, 70s, there were only so many of these big supercomputers and these systems that were around. Lots of big colleges and military installations, defense contractors, banks, certain big entities had these resources. And if let's just keep it in the academic world, you're a researcher, you work at one college, but your college doesn't have a mainframe, but you need to crunch the numbers of a huge set of numbers. You would have to take all your data, back then possibly in the form of punch cards, but maybe whatever format, digital, you have to take all your data. You'd have to call up somebody, say, San Francisco or New York or someplace where some other university you were partnered with had a huge, um, supercomputer and a mainframe back in, and you would say, hey, I want to book some time. And it's okay, we got some 2 weeks from now, whatever. You'd have to then drive over there, fly out there with your data, sit down and put all your data in, read all your punch cards in, let it run all its stuff, and then get your printout, get your data back, get your punch cards back, and then go back home and do your paper and write up your analysis and do your stuff. Well, that's hugely inefficient, right? I've had to travel, I'm having to carry all this around. So when you get down to it, we had 3 things that were the killer first sort of 3 apps. I always look at them this way. Telnet for remote access to a system, FTP to transfer files, and email. And email is really the true first killer and still one of the most popular form of communication, despite all these messaging apps, especially in the business world. Email is still commonly used to have a trail and all this. But now what I could do when the internet came around is I could send an email to somebody at another campus and say, hey, I need some time on your mainframe. Okay, we got some in 2 weeks. And instead of having to worry about travel or anything else, in 2 weeks, when my time came, I would use FTP to transfer my data file over to that server. I would use Telnet to connect to that server. And then I would run the program, let it run in chunk. When it got all of its processing done, I'd use FTP to pull back my data results. Hey, great. Now we're more, of course, because and given back then, especially, and even today, supercomputers are still huge investments. And so we want them being used. We don't want, the one in, say, West Coast or East Coast, some campus, to everybody goes home at 5 and nobody's using it, right? Now we can have people connect in at different times. And so those were sort of the killer applications, this remote ability to run. But of course, Telnet and FTP are both sort of on the outs because they're not secure. The information, like literally your username and password, are passed in clear text over the wire. In those early days of the early innocent internet, when it was just university people and defense contractors and researchers, there was a degree of, innocence and assumed, everybody being good. And that's changed. We can't trust that anymore. We don't trust anything anymore. So we've developed other protocols like secure copy and secure shell. And that's what we're going to use. So if you need to give remote access to somebody, to a machine like that, or you want to remotely manage a router, you're not going to want to use Telnet, because anybody along the way who has access to the routers and hops that take you from your house to that machine or from one office to the other office on the side of the country could theoretically capture your password and username and thus get back in. Whereas with secure shell, sort of like with secure web, we're going to have an encryption signal so nobody along the way can capture that information and see what we're doing. So at the end of the day, it really comes down to implementing this secure version of a protocol 9 times out of 10. Now, there are occasions when that is not possible. There could be legacy equipment. Big companies still have, it amazes me sometimes, some of the stuff that is still running. And even today, for various reasons, maybe it's just, an embedded device kind of thing. Part of it, I saw this actually not too long ago, last year, at a client. I have a client that does commercial printing. They do all kinds of large format signs and things and fancy stuff. And I was doing an assessment of their system, and I scanned their entire network, and I was blown away to find a Telnet port open on a particular IP address. And I'm like, what in the heck is running Telnet? And it was a management interface for a high-end printer. So you could Telnet in and give it commands and things. And that just blew me away. And this wasn't like a 20-year-old printer. This was a relatively new high-dollar piece of equipment that had a Telnet interface. But they were just keeping that. They felt, okay, it's going to be inside somebody's business. Nobody's going to be able to get to access to it from the outside. It's safe enough. We can use it. We don't have to run the overhead of the more elaborate encryption. And they made that choice. And we are seeing it still be implemented in certain IoT devices and other places because it's much smaller. It runs much more efficient. But it is not secure in and of itself. By definition, this stuff is in plain text. So generally speaking, you want to use the secure protocols. But if you run into a situation where you can't, or some device, some management interface, that is how you manage it, then you're going to have to protect that in some other way. You are not going to want to allow Telnet from the outside because if so, then they can Telnet right in and break that printer, make it do something else, or Telnet into a router it used to be very common that that was the way. Telnet was the tool. You connected to everything with Telnet, but we're moving, thankfully, almost everything into secure shell. But you will run into Telnet. And if you have it, then many times, like if, for example, let's just say you had some piece of equipment that had a Telnet interface to manage it, and it's inside your network. Well, you do not want to open up Telnet through your firewall and just let your admin at home Telnet all the way in, because if you do that, the attacker can get in. And the attacker, can just pound away at it and try to brute force in, or maybe by exploiting something else, get into your network just on the edge, but enough that they can listen, capture packets, and then they'll see you log in next time through that. And now they're in. So instead, what you might do is use secure shell to appoint a machine inside the network that you trust, and only it can telnet to that machine. And you set up even maybe whitelist and blacklist to protect it, so that yes, you are giving some degree, but it's not just opening telnet to the world kind of thing. FTP you'll still find used, even though I think that's fixing to fall. I've heard reports that the browsers are going to remove the ability to browse FTP. A lot of times people don't know it, but when they go to a software site, a game company, whatever, and they're downloading a driver or something, some kind of software, many times it would use the FTP protocol. Even though it wasn't secure, nobody cared because you were just downloading a new video driver or something. But it is an old unsecure protocol, and so people, once again, that those protocols are being phased out. You will still find FTP servers available and in use, and if they are in use, then they need to be secure. I run FTP servers for some clients. So, for example, a client that needs to take big files in from their customers, big, whatever, doesn't matter. Big file, something they can't attach to an email. Now, well, there's all these sites today, but some of my clients just like that old school model. Well, I've had to set that up in such a secure way so that when people try to, upload files, that their clients can do so. But I have to also protect it so that some hacker doesn't try to upload something and be able to make it run and try to exploit the system. So I do a number of things, from locking it down as secure as possible to making it to where anything that's uploaded can't be seen. That's also just a privacy reason. One client puts their file in, another client comes in and they can see the other client's file. That maybe they're competitors, maybe they don't, we don't want that. So we lock it all down and actually use some permissions and scripting on the back end to actually cheat. I move stuff instantly, and I re-own and reposition the files, re-permission the files, so that even if somebody, and it's actually funny to me because that's actually how I can do some degree of security research myself occasionally, is I'll see the latest thing that somebody's trying to do because they uploaded it to one of those FTP servers, but then they can't figure out how to run it. And they upload some script or something, like we were talking about earlier. And that, in their case, it's going to do something nefarious, try to take over or download something, infect my machine. But because I changed the naming, I changed the permissions, and I changed the ownership and move it, so it's not where they expect it to be. Even if there was some way for them to try to run a remote code execution, it's not, they're going to get a file not found. It's not there. They can't, there's no execute permission, things like that. So, generally secure protocols are about knowing which ones are the secure ones. HTTPS over HTTP, secure shell over telnet, secure POP over POP, secure IMAP over, stuff like that. You're always wanting to implement the secure protocols. But if for whatever reason, backwards compatibility, legacy, some kind of management interface on an old embedded device, manufacturing equipment, whatever, that still has some of these old protocols, then you're going to have to wrap them in additional layers of security. I've even seen customers that say, the only way we're going to let that admin work from home is he's going to have to VPN, which is an encrypted virtual private network, into the network. And then once they're inside, they can then connect. Otherwise, you walk into that server closet and log into that machine locally, or plug a cable in and get into it and configure it. And maybe you turn off that telnet. So anyway, that's secure protocols. There's a lot of additional information on there's other protocols, RIP and MIME, and all just on and on. Some of the repeat of some of those are the routing protocols we talked about on network. So so then as we move on, lesson 8 is about secure networks and systems. And it's a conceptual chapter that's tied to how do you design things from a secure point of view. Well, you take some of those best practices all the way back from the intro course, network, intro to security foundations, the idea of layered defenses and limiting and all those factors. You take them into account when you design a network and you design any system. And so a network, of course, could be just a network of a small office. It could be the globe spanning enterprise network. You got to think about and design things securely, segment your network pieces so that if somebody gets into one, they can't necessarily move easily to another, that kind of thing. And we think about those things. When we're designing a system, the system might be one machine. It might be a whole data center. These are kind of broad, terms they can cover, but the thought process is still the same. Okay, I'm going to set up one web server. It's going to be my main web server. It's going to have personal information. So I'm going to set it up and I'm going to turn everything else off on that thing but the web server. And I'm going to lock this thing down, make sure it's fully patched and updated. If it's really that critical, I may put an intrusion detection system, a host, what we call a host-based intrusion detection, right on that machine. So right there, it's looking at stuff. And that's in addition to those layers of firewall and intrusion detection and prevention that are going on at the network layer. So many times it's about, that's why I was so, it's been a while, I know, since you took that course, but if you need to, go back and review that lesson, that 5 and 6, 4 and 5 in the first lessons from Security Intro to Security Foundations, all about defense in depth, layered security, limiting, simplicity, all these different really, really cool principles. And so there's a lot of best practices. We talk in the lesson a fair amount about secure network design and secure system design. And then you have an assignment, and I don't want to give the answers away by any stretch, but the idea is you've got to sort of figure out what kinds of things, and it's just still kind of high level, but we talked in the previous lesson about all the different types of network components, routers, firewalls, so we've got this sort of topology that you've got to look at and got to decide where certain things go, is basically my hint. And so think about it from that point of view. If I'm trying to isolate and protect, what would I want to do? What kinds of things would go in those spots? When we move into lesson 9, we give you your first experience with programming, at least in principle in our program, in last week and a little bit beginning today, on shell scripting. And though you're going to take a programming class later in a program on Python, and the idea is that you are, a solid understanding of basic programming concepts and can write scripts and do things to automate your task and security and system admin, and that's why they're covered. You need to know about deployment and development at a broader level, and you're going to learn more on this as well in a web application security class. But secure deployment really can involve two things. In most people's minds, they're thinking about patching. And it's very important that you keep your organization's systems, computers, routers, switches, everything patched. But by the same token, you have to be cautious because patches can break things. So for example, years ago in a company I worked for, we had this happen. One day, we were a make shop, much like I am to this day. We had graphics designers on Macintosh machines, Apple machines. We had accounting and salespeople and other people on Windows machines. We had Linux servers, Unix servers, Windows and Mac servers. So we had this mixed environment, and all this was talking and working, and it was all beautiful as far as we were concerned. One day, Microsoft rolled out a patch. That patch was to the SMB, or Server Message Block Protocol, and it was supposed to fix, supposedly a security patch, to fix a hole in their implementation of SMB, Server Message Block Protocol. And what happened is that, lo and behold, they're fixing this security hole, broke every Windows machine's ability to see the Mac and Linux machines, because now they weren't working. They weren't talking right. That was not intentional. It was fixed like a week or so, a few weeks later with the next patch. But technically, all of a sudden, all of our operations just didn't quite come to a halt, but a large number of things, like a designer might do a proof, put it on a server, and the salesperson would get that file and mail it. And everything was seamless, and nobody cared. Nobody had to know. It was set up so beautifully. We really liked our very, open system, cross-platform. So a designer on a Mac would put a file on this Linux server, and the Windows machine would connect to that, get that PDF, send it to the client as a proof. They could get the comments back, put it back for the designer, and we had this interoperation between all these OSs, and everything was running just beautifully until the day of that patch. And when that patch happened, it totally screwed up everything at the headquarters for that whole day. It took us a while. The first person who reports it, calls back to IT, hey, I can't get to the server. Somebody goes over, tries to change, check passwords and all the standard, IT kind of support stuff. Still can't figure out how to get on. Then all of a sudden there's another call, and then another call. And all of a sudden half the staff can't get to here or there. And we're like, okay, it's all the Windows machines. Okay, we got that. Of course, it's like a Wednesday, so it's okay. Well, Apaches usually happen, and okay, let's go. So we start digging. Sure enough, half the morning's gone, and we figured out that a Microsoft patch that got pushed automatically last night had broken that connectivity. So then we had to run around to every Windows machine that needed this, at least in the short term, and uninstall that patch and revert back to the previous patch level so that they could once again connect. So while there was a security bug that was being fixed, theoretically something that we wanted fixed, so that some virus that got in couldn't use SMB to run around all the Windows machines, we had to roll it back because we couldn't break the company. We needed to get proofs out. We needed to get files transferred. And so secure deployment from a patch point of view is a patch management model where many times, and this is what we did, we literally had a PC and a Macintosh machine that did get other uses than just this purpose. But we turned off automatic updates in our company at that point. It was a lesson learned, bad lesson learned when we lost half a day of productivity. So we turned off automatic updates. And this is an issue now with Windows 10 because Microsoft pushes out updates. And even at the enterprise level, there's only so much control over how much you can control that these days. And I understand why Microsoft wants to try to push and make things safer. But because those changes can break other things, corporate IT guys and girls are just going crazy. They've been asking for Microsoft to push less patches to give them more control. There's a whole series of threads and debate on this topic going on out there because this is the trade-off. What we would start doing is we left those two machines, one Mac and one PC, running automatic updates. And every time a patch came out, we would run a series of tests on those machines to make sure, can they still talk to all of them? Or can they get to the font server? Can they get to the file server? Can they get to the printers? Can they do everything? If they can, then we immediately pushed all the rest of the patches out. But if we ran into any other problem, which we did one other time, that saved us. And that was worth it. That's a model of secure deployment. So you're testing it before you push it out. And then this applies to software development as well. And this is a hugely important concept. It's something that you're going to hear me say a couple more times at different points in the program, and I already have in earlier courses, but it is highly common for cybersecurity professionals to work within the dev team or to work with the development team. More and more companies have at least an elaborate website, if not apps, iOS apps and everything, Android apps and all this stuff that helps power their company. Every time one of those pieces of software gets updated, it is adding new features, fixing bugs, whatever. It can also break something or cause a security hole. And so generally speaking, there's a whole series of steps. The most common model is what we call a dev model. 4 steps: dev, testing, staging, and then production. So the idea is that the developers write their code. They try to do their own test. They can do things like unit test. We can and guide some things. We can have some testing done right there to make sure maybe no bad calls are being made, risky things are being done within the code. But then once that is pushed into the testing phase, we have a testing environment. We have a server that's like the web server. Or like, we have machines, we have clients, we have phones and tablets that are going to be what we test on. And so we ultimately, push the code to there and test it. Once again, security may be involved in those steps of testing. If it's made it through that phase, then we're going to push it to staging. Staging is generally a server, let's look and use the website example, that is almost identical. We might have just had a testing server. It's just a local one inside the department. But this one now might be in the cloud, or it might be almost it may even technically be our backup web server that we use as staging. But it's almost identical or as close as possible to, and it could be virtualized, but still to the live environment. And then we're going to do more. That's the staging. So something was developed and tested at that stage. Then it was put into testing. It was tested at that stage. Then it was put into staging stage, and it's tested again. We want to make sure, okay, now in a more like life realistic production environment, is everything working? Are there any holes? Are there any bugs? Does it crash? Does it cause any problem? And only after it makes it through all those steps and passes all the various tests, both functional and security, then we'll push it to production and thus live. Now, we also have this model of continuous development nowadays where things are constantly being updated. Like think about Facebook or any of those type of sites. You don't hear about Facebook 2.2 or whatever, like, we used to get Windows 10 or Windows 8 or whatever. We don't have a numbering. There isn't. Internally, they probably keep track, but they just push features out. But they're doing this too. That feature is being developed and tested. It's tested at the testing stage. Again, staged and tested at a higher level, finally pushed into production. And this kind of stuff is just ongoing all the time. And so obviously our job in security is then to make sure we're helping make sure that those testing is going well. And then even once it goes live, we may be back in doing vulnerability and penetration testing to make sure. So it's important to understand security deployment, and it can apply to patch management, patching routers, patching servers, patching everything. You don't want to push a patch out to all your routers and have it bring your whole network down. That would be colossal bad, right? Now you're having to run around, roll back all, or maybe it didn't bring everything down, but it opened a huge gaping hole because you just pushed it out. And then there, 3 weeks later, some hacker figures out the 0-day, exploit, and boom, they're in every router like that, everyone they can find, and they're all over your system, they're through your firewall, they're wherever. So once again, we generally want to roll things out in stages. We want to test them. We put them, like I said, even patches. You can have systems that you test. Sometimes in big organizations, patches are rolled out even on a rolling basis, so that, because, okay, sure, we tested on those 2 machines, but then I go push it to 100 and it still breaks 2 of them. Well, or maybe it breaks 20 of them, 20%. And it might have gotten past those single tests. So maybe I only want to roll out to 20 to 20. And if I had any problem, I stop and figure out why that is. Oh, if this particular driver, so when this graphics card and this thing come together, we have a problem. So I'm not going to patch those machines. I'm going to patch the others so that I can keep working. So anyway, secure deployment is lesson 9. Very important to understand it both from a patch side as well as the software development lifecycle side, because yes, that is very critical. And you're actually, there's a whole group of jobs, and technically some security people in many organizations are part of this, what's called DevOps now, which is the idea that you have system administrators who are targeted at the development teams. They're not just general IT for the whole company, help desk and all that. Their job is to help the developers spin up environments, test things, and they're the IT people, in effect, the DevOps, the operations people for the dev team. And many security people have a dev security ops person who's there to help test. So depending upon how critical it is and how big, if you're a bank and you got a website and a mobile app and all this stuff, and you roll out updates and there's a bug and somebody can break in and rip off all your customers' records, that would be a huge failure, right? So we want to avoid that. So that's why it's important. The last thing we're going to talk about today, as I run out of time, and we will talk about much, much more, but is the implications of embedded and IoT. Embedded systems are basically the idea of taking computing power and generally connectivity, but at least computing power, and putting it in something. You, if you have a fairly modern car, are driving around in a car that has multiple embedded systems. So there's a system that helps drive those anti-lock brakes. It's a chip, and it handles that pushing on the brakes so you don't lock up your brakes. You've got systems that are running the cooling system. You got systems that are running the throttling or ignition and the firing of all the pistons and stuff. A modern car might have a dozen embedded systems. These are individual computers, mini computers. They do a particular thing. A manufacturing facility might have dozens that help run all the equipment, run the assembly lines, run the conveyors, run everything. Those are embedded systems. And historically, that's where we've seen them. Embedded systems have been in big things like planes, cars. They've been in manufacturing processes. There's a particular thing called SCADA. That's a type of control mechanism and framework for those type of devices. And matter of fact, has been the target of a lot of attacks. But so those, though, are growing more, or automating and putting more and more embedded systems into more and more things. So our cars have more and more. Our planes have more and more. I mean, the fighter jets our military fly many of them, some of them at least, many of them cannot fly without those systems. They are not inherently stable craft if there aren't all these little micro adjustments being made by the system for the pilot. The pilot tells it where to go, but all these little adjustments to keep it totally stable at those high speeds and at those high turns and banks and things is an embedded system, a smart computer system. But we're also seeing it in more and more in manufacturing. We're seeing it in, of course, refining and power plants and all over. These systems are everywhere. And they're a prime target for attack. As a matter of fact, I predict that I'm surprised it did not happen in 2018 because it almost happened in 2017, where a digital hack almost blew up an oil refinery in the Middle East. And literally, the people who've seen the code, and I have not, but I've read all the reports, there was just a bug in the code or it would have worked. They came that close. Somebody came that close to blowing up an oil refinery. Whoever did it, very likely certain nation states, when they attacked the Iranian centrifuges using the Stuxnet virus, that was attacking an embedded system and the SCADA controls that power it. They basically told the control room everything's fine, and then they spun those bad boys up until they broke, and they burned themselves up and set them back. That same type of attack vector was used at that refinery. And at some point, I'm surprised it didn't happen this year. We've only got a few more days left, so hopefully it won't. But my prediction is 2019, we will see something go boom. And once the analysis is done, it's going to be because somebody didn't physically go in, didn't plant a bomb. They hacked that system. They turned off the cooling of a power plant, but told the power plant control room everything was fine, and it went boom. Something like that's going to happen. If it's not 2019, I mean, I thought it was going to happen this year, so I'm already wrong, so I can make predictions all day. I really do think it's probably going to happen in 2019 if it doesn't in the next few days. So far, it hasn't in 2018, but we came really close in 2017 to that happening. So then what is IoT? Well, we talked about that a few times, but IoT is really just embedded systems in everything. Your dog's color, your smart Nest thermostat, your baby cam, your home routers. It's amazing. Home routers are most of the time, little mini Linux computers. They're running a Linux kernel in there. They give you a web interface so you can go in and set up your Wi-Fi password and stuff like that. And of course, a lot of these devices that like smart microwaves, smart refrigerators, smart whatever, and we're going to have a bunch of them brought home this year for Christmas. And we're going to grow. There are going to be more out there. And of course, a lot of people just come home, plug the darn thing in, and leave the passwords at the default. Don't change anything. Don't remember to ever update it, if it's even updatable. And then it can become a target of attack that can let somebody break into your home network or use that to attack somebody else, tie them together into a botnet, etc. So there's a lot of information about that. And we will talk much more. We'll talk more on these in other places as the time goes on. I'm out of time for today. This is my last workshop. I've had to do a couple today. I'm going to start downloading these, and I will get them uploaded and posted into the LMS. I have office hours happening with various people over the next few hours. And I shouldn't say one-on-one meetings with various people. So I'll see some of you very soon. And I do have an office hour later this evening as well that'll be available. Thanks. Talk to you soon.